Good day everyone. Planes part 3. Before starting the lesson, let me tell you one thing. Any student in 12th standard, if you have any doubts, if you want to clarify certain concepts, I have got a group in WhatsApp. Relax and learn. This is my number. This is the WhatsApp as well as my phone number. You can just write your name and your school. If you are in some other city, write that name of the city. It is totally free. I will enroll you, I will join you in that group. Then, any doubts you can post in that group, and definitely I will answer either by text, that is working out, or by audio. I thought this might benefit many students since you can learn at the comfort of your home, isn't it? And at your convenient time. Because when I post my reply, you can say it at any time convenient to you. So, please, if you feel some guidance, you need some help, you need not hesitate. Message me. You can tell your friends and classmates in 12th, wherever they are, in whichever school they study, let them also join, so that I just want to do this as a small service, what is possible from my side. Okay, thank you, share it. Now let me go on to the lesson. Now planes part 3. You have already learnt how to find the equation of a plane passing through one point and perpendicular to two planes, passing through 2 points and perpendicular to one plane, passing through 3 non-collinear points, right? Now today, let us see a new equation. You know, when 2 lines are there, they will intersect over a point, isn't it? When 2 planes are there, now supposing you have, this is one plane, this is one plane. Where do they intersect? They intersect over a line, isn't it? 2 planes intersect over a line. So now, today we are going to learn how to find the equation of a plane which passes through the intersection of 2 other planes. Okay? So now, let us take the 2 planes are a1x plus b1y plus c1z plus d1 is equal to 0 and a2x plus b2y plus c2z plus d2 is equal to 0. These are the 2 planes. Now these 2 planes will intersect over a line. I want to find out the equation of a plane passing through that line of intersection. That is given by the first plane equation, okay, plus lambda times the second plane equation is equal to 0. That's all. Here, lambda is the only unknown here, because you know the 2 equations are given already. To find that value of that unknown lambda, they will give you some other information. It may be a point, it may be another perpendicular plane, it may be some distance from the origin or whatever it is. So, it is a bit simple. You can write this and find the value of lambda and substitute, that's all. Okay? So now, let us see 3 different types in that. That is giving 3 different conditions to evaluate the lambda. Okay? Example 1. Find the equation of the plane passing through the intersection of the planes. R vector dot 2i cap plus j cap plus 3 cap k cap is equal to 7, and R vector dot 2i cap plus 5j cap plus 3 k cap is equal to 9, and passing through the point 2, 1, 3. Here, the equation of the 2 planes are given in vector form. So, first we have to write it in the vector form, convert it into Cartesian form, and then proceed. Okay? So, now let us write the first equation. R vector dot 2i cap plus j cap plus 3 k cap is equal to 7. Now I will write the Cartesian form for it. So the Cartesian form is 2x plus y plus 3z. Let me bring that constant 7 to this side. So minus 7 is equal to 0. This is also the plane one. Okay. Now let us write the equation of the second plane. R vector dot 2i cap plus 5j cap plus 3k cap is equal to 9. Write the Cartesian form for this also. The Cartesian form, that will be 2x plus 5y plus 3z minus 9 is equal to 0, right? So you have got now two plane equations in Cartesian form. What is the equation of a plane passing through the intersection of two planes? First equation plus lambda times the second equation is equal to 0, right? So let us write equation of the plane passing through the intersection of, okay, passing through the intersection of, they can give intersection or line of intersection, both are same. Intersection of planes 1 and 2 is, you have to write the first equation, that is 2x plus y plus 3z minus 7 plus lambda times, write the second equation, 2x plus 5y plus 3z minus 9 is equal to 0. We can call it equation 3. This is the equation of the required plane. We want to find 3. Here the unknown is lambda. Now this plane 3 passes through the point 2, 1, 3. So now plane 3 passes through 2, 1, 3. So you have to substitute x is equal to 2, y is equal to 1 and z is equal to 3 in equation 3 now. So what will we get now? 2 2s are 4. Okay. Then here that is 1. So you will get 1. Then 3 into 3, that will be 9. Then there is a minus 7 plus lambda times 2 into 2 you will get 4. 5 into 1 you will get 5. 3 into 3 that is 9 minus 9, that is equal to 0, right? The plus 9 and minus 9 you can cancel here. So what will you get here? You will get 5, 14 minus 7, so 7 plus 9 lambda is equal to 0, which gives you lambda is equal to minus 7 by 9. Once you find lambda, substitute it in equation 3, okay? What you are going to do? Substitute lambda is equal to minus 7 by 9 in the equation of plane 3. So you will get now 2x plus y plus 3z minus 7 by 9 into 2x plus 5y plus 3z minus 9 is equal to 0. Now, don't be multiplying the second equation by 7 by 9 and getting fractions and all. Just like LCM, no? Cross multiply. Bring the 9 here. So, you will get now 9 into 2x plus y plus 3z minus 7 into 2x plus 5y plus 3z minus 9 is equal to 0. Let us properly write the equation combining the x terms, y terms like that. So here 18x minus 14x, that will give you 4x. 9y minus 35y, so you will get minus 26y plus 27z minus 21z, so you will get 6z minus 63 plus 63, so that will, they will cancel each other. Now divide by 2 throughout. 2x minus 13y plus 3z is equal to 0. But in the original sum, they have given the equation of the planes in vector form. So now let us write it. The vector equation is, okay, r vector dot, you will get 2i cap minus 13j cap plus 3k cap is equal to 0. Is it clear? So first what do? Two plane equations are given. You write the equation of the plane passing through planes 1 and 2. Lambda is the unknown. They have given the plane passes through some point. Substitute that point in the place of x, y, z. Get the value of lambda. Substitute it in equation 3 and then you simplify it. If they ask you the vector equation or if this is given in vector form, give the answer in vector. If it is given in Cartesian form, give the answer in Cartesian way. This is a very simple model only. Is it clear? Let us move on to the next model. Example 2. Find the equation of the plane passing through the intersection of the planes. Two plane equations are given in Cartesian form. Here, they have not given you the point. Instead, they have given another plane which is perpendicular. Okay? So, to find lambda, we have to make use of this fact only. So, the beginning, let us start in the same way. Let us write the first equation, that is 2x minus 3y plus z minus 4 is equal to 0 is equation 1. X minus y plus z plus 1 is equal to 0, that is equation 2. So now we want to find the equation of a plane passing through the intersection of these two planes. Okay. So now let us write it. Equation of the plane passing through the intersection of planes 1 and 2. Intersection of planes 1 and 2 is the first plane equation, right? Plus lambda times. Okay. The second plane equation, that is x minus y plus z plus 1 is equal to 0. This is the equation which we want to find. This is the equation of the required plane, plane 3. Here, as you know, lambda is the only unknown. But here, they have given another perpendicular plane. When two planes are perpendicular, you know that normals are also perpendicular, isn't it? When the two normals are perpendicular, what is the condition? The sum of the product of the direction ratios, that is a1, a2 plus b1, b2 plus c1, c2, that will be equal to 0. That means we should know the direction ratios. If it is in this format, it is difficult to find. So let me write it in the proper format, that is x into something plus y into something like that. So now I will combine the x terms. X into 2 plus lambda. Okay. Always have a plus here. Plus y into minus 3 minus lambda plus z into 1 plus lambda. The constant term minus 4 plus lambda is equal to 0. This is also equation 3. Okay, we have just rearranged the terms properly. So here you know the drs of the normal. Okay, the drs of the normal, we will take them as a1, b1, c1. That will be now 2 plus lambda, comma, minus 3 minus lambda and 1 plus lambda. Okay. Now let us write this plane, that is the perpendicular plane, that is x plus 2y minus 3z plus 6 is equal to 0. Okay. Now drs of the normal to this plane, let us take them as a2, b2, c2. That will be 1 comma 2 comma minus 3. Now you know plane 3 and 4 are perpendicular, isn't it? Planes 3 and 4 are perpendicular. They have given. Therefore, their normals are perpendicular. So you know A1 A2 plus B1 B2 plus C1 C2 is equal to 0. That is the sum of the product of the direction ratios is equal to 0. So now let us do 1 into 2 plus lambda, okay, plus 2 into minus 3 minus lambda minus 3 into 1 plus lambda is equal to 0. We have to find the value of lambda by expanding. So what will we get? 2 plus lambda minus 6 minus 2 lambda minus 3 lambda is equal to 0. So you will get minus 5 lambda plus lambda. So minus 4 lambda. 2 minus 6 minus 3. So here it is minus 9 plus 2. So minus 7 is equal to 0. So minus 4 lambda is equal to 7. Lambda is equal to minus 7 by 4. Now we have to substitute in plane 3. Now go to the original this one. No, don't go to this one. This will be easier. So now you write. Therefore, equation of the required plane. Okay. Equation of the required plane is. Now let me write this part as it is. 2x minus 3y plus z minus 4. Instead of lambda, let me write minus 7 by 4. Write the second one. X minus y plus z plus 1 is equal to 0. I have already told you, bring this denominator 4 there, okay? So you will get 4 into 2x minus 3y plus z minus 4 minus 7 into x minus y plus z plus 1 is equal to 0. Now let us write it properly. 8x minus 7x, so x, right? Minus 12y plus 7y, so minus 5y plus 4z minus 7z, so minus 3z minus 16 minus 7, so minus 23, that is equal to 0. This is the equation of the required plane. So here do you understand? When a perpendicular plane is given, what concept we are using? When two planes are perpendicular, their normals are also perpendicular. So the sum of the product of the DRs is equal to 0. A1, A2 plus B1, B2 plus C1, C2 is 0. Using that concept, you are finding the value of lambda, then substituting in equation 3. Okay? Now, let us do one more model now. Example 3. Find the equation of the plane through the line of intersection of the planes. Two plane equations are given in vector form, which is at a unit distance from the origin. Here, what they have given to evaluate the lambda, the required plane, that is the plane you are going to find out, is at a unit distance from the origin. So using that concept, now we have to proceed. Okay. Anyway, the beginning, let us first start now. The first equation they have given is r vector dot I cap plus 3j cap plus 6 is equal to 0. What to write now? Cartesian form. Okay. So the Cartesian form will be, the Cartesian form is x plus 3y plus 6 is equal to 0. Okay. Let me write the second equation. R vector dot 3i cap minus j cap minus 4k cap is equal to 0. Let me write the Cartesian form for this. The Cartesian form is 3x minus y minus 4z is equal to 0, right? So now we have got two plane equations in Cartesian form. What is the equation of the plane passing through the intersection of these two planes? Equation of the plane passing through the intersection of, okay, passing through the intersection of planes 1 and 2 is Write the first equation, x plus 3y plus 6 plus lambda times the second equation. This is 3 and this is what you are going to find out. Now, what is the concept you are going to use? This plane 3 is at a unit distance from the origin. What is unit distance? The distance is 1. Unity means 1. Now, you should know one formula. What is the distance of a plane from the origin? D by root of a squared plus b squared plus c squared. You will have a modulus because distance will always be positive, right? So now this should be in the proper format. No, we have to write it as ax plus by plus cz plus d. So let me write it now. X into 1 plus 3 lambda plus y into 3 minus lambda and plus z into, here there is nothing, here you have minus 4 lambda. Coming to the constants, you have a 6 here, here you don't have a constant, is equal to 0. This is your equation 3. Is it clear? So now x into, that is, this is A, this is B, this is C, that is D. I think let me write it now. I will compare it with ax plus by plus cz plus d is equal to 0. Okay, comparing, I will get a is equal to 1 plus 3 lambda, b is equal to 3 minus lambda, c is equal to minus 4 lambda and d is equal to 6. Okay, now I know the distance from the origin to a plane ax plus by plus cz plus d is equal to 0 is d by root of a square plus b square plus c square. Okay, so using this, that distance is given to be unity now. So we will be equating it to 1. So now we will get, what is d now? 6 by root of a squared, that is 1 plus 3 lambda the whole square plus b square 3 minus lambda the whole square plus c square minus 4 lambda square. That will be equal to 1. Okay. So now you will get 6 by, if you expand it, you will be getting 1 plus 9 lambda square plus 6 lambda. Expand this, plus 9 plus lambda square minus 6 lambda. This is plus 16 lambda square. That will be equal to 1. Because you have a modulus here, we have to take both the plus or minus sign because lambda is involved here. So we can put the plus or minus sign either on this side or on the other side. Both are same. So now I will write 6 by, I will combine the terms. This is 9 plus 1, 10. So 26 lambda square. Okay. Then this 6 lambda, that will go. So I am having 1 plus 9, 10. That is equal to plus or minus 1. Now let us square both sides so that we can remove the square root. So what will you get now? 36 by 26 lambda square plus 10. That you can take it as either plus 1 or 36 by 26 lambda square plus, anyway when you square it, it's going to become plus 1. Anyway, it's a quadratic and we will be getting that. That's enough. Okay. So now when you square it, you are going to get plus 1. So you will get 36 is equal to 26 lambda square plus 10. So 26 lambda square will be 26. So lambda will be plus or minus 1. Now you will be actually getting two equations, isn't it? Now if you go to this equation 3, first you have to substitute lambda is equal to plus 1. Then you have to substitute lambda is equal to minus 1. And then you should get the vector equation of the format. That will be your answer. Is it clear up to this now? So you have evaluated the lambda. Now you have got two values for lambda. Now let us continue. First I will put lambda is equal to 1. Okay. So what will I get now? X plus 3y plus 6 plus 3x minus y minus 4z is equal to 0. So 4x plus 2y minus 4z plus 6 is equal to 0. Divide by 2. That will give you 2x plus y minus 2z plus 3 is equal to 0. The vector equation will be r vector dot 2 cap plus j cap minus 2k cap plus 3 is equal to 0. Now I will put lambda is equal to minus 1. So now I will get x plus 3y, lambda is equal to minus 1. 3y plus 6. So minus 3x plus y plus 4z is equal to 0. Okay. So I will get minus 2x plus 4y plus 4z plus 6 is equal to 0. We can simplify this also. Minus x plus 2y plus 2z plus 3 is equal to 0. Usually we don't keep the first term as negative. So we will get x minus 2y minus 2z minus 3 is equal to 0. So now the vector form will be, the vector equation will be r vector dot I cap minus 2j cap minus 2k cap. This minus 3 I can write here as 3. So this is one equation, this is another equation. These two are the equations of the required planes. Hope these three models are clear to you. That is how to find the equation of a plane passing through the intersection of two planes and passing through a point perpendicular to a plane, or given the perpendicular distance from the origin is unity. They can give instead of unity some other number also. Okay. So hope this is clear to you. Next video, let us see some other concept, some other formulae and sums. Subscribe if you have not subscribed already. Share this video to your friends and classmates. Thank you.